Hello students, welcome to the next lecture on the CSIR net and the GATE mathematics questions. Today we will discuss about the previous year questions from the year 2009 to 2021 related to the eigenvalue. This is the part 1 of this eigenvalue. Myself Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg for the various videos. Otherwise you can simply scan this code and you can join with the WhatsApp group. The link is also given in the description part. We have tried to explain you the 30 questions in this part 1 and the remaining 40 questions 40 in my part 2 that will be uploaded after this video related to this 2009 to 2023. We will solve all these 30 questions with the help of the shortcut trick. So what is the shortcut tricks for you? Remember always, whenever you have the matrix and whenever there is a related to the eigenvalue, remember the sum of the eigenvalue is always with a trace of the matrix and the product of the eigenvalue is determinant of A. So this is the simple trick we will use in all these 30 questions. So let's start with this one. The characteristics polynomial of this. So look at that. The one way is you can find these equations. You can try to solve this and you can get the answer. But there is no need. What is the shortcut trick is? What is the trace of A? You can see the trace of A is minus of A. So clearly say that this is the trace of A is minus of A. Trace of A means sum of the eigenvalue. Sum of the eigenvalue means sum of the roots. So and here you can see when you multiply them it will be A, B, C. So the right answer is only A. In this case, what is the coefficient of x square? Only the coefficient of x square is A is in this example. Look at it in this case. Here A is any of them, n is greater than 1. Is it given to you what is the value of the n? So you can consider n is my 2 or you can consider n is 3, that is upon your choice. So if I consider n is my 2, then it will be 2 cross 2. What is the meaning of this line? A square minus 7a plus of 12i. So what is the meaning of that? Trace of A is my 7, determinant of A is my 12. That's the meaning. Now what is the meaning of that? Determinant is non-zero, it means A is invertible is the right answer. Trace of A or determinant of A is my 12, so it means D is equal to here. So clearly say that it is not satisfied. Is it satisfied? No. So the trace, what is the trace is 7, again it is not satisfied. 49 minus 49 plus 12, n is my 2, it is not 0. So this is also cancel out. Right answer is only A. Look about the another one. So A is my invertible 5 cross 5 matrix. So what is the nature of this A? Is it symmetric? Is it skew symmetric? Is it Hermitian? Is there anything given to you in the statement? No. So you can simply consider A is my I, such that the characteristics polynomial of A and the characteristics polynomial of A inverse is same. So that's very simple. We all know the characteristics polynomial of A and what is the A inverse? I. So it means this condition satisfied. Now what is the determinant of, so what is the eigenvalue of A? 1 and 1. What is the eigenvalue of the A square? 1 and 1. So what is the determinant of A square is 1. So that could be the answer. A5. What is the determinant of A5 is again 1, 1, 1. 1 and 1, so the determinant is also 1. You can see trace of A square. What is the trace of A square? Trace of A square is my 2, which is not 1, so this option is cancelled out. Trace of A5 is my 5, this option is cancelled out. Now out of these two options, if I consider A is my minus of I, A inverse is also minus I. What is the eigenvalue of the A? Minus 1, minus 1. What is the trace of A square? What is the eigenvalue of the A square? Eigenvalue of the A square is 1 and 1. What is the eigenvalue of the A5 is minus 1, minus 1. So it's a 5 times. It's a 5 times. So what is the determinant of this? It's a plus 1. Determinant of A is minus 1. So this option is again cancelled. Correct option is only A is the right answer. Okay, so A is a 5 cross 5, so it has the 5 eigenvalues. Trace is 15, it means the sum of them is a 15. One of the eigenvalues is 2, 3 is another eigenvalue, algebraic multiplicity is 2. What is the meaning of the algebraic multiplicity? Since eigenvalues are my 2 and 3, algebraic multiplicity is 2. It means the 2 is written the 2 times, 3 is written in the here. So these are my 4 eigenvalue. Sum of them is my 15. So what is that? It's a 9, 11. So it's a 10, it's a 5. And you have to find the determinant of A. So these are my eigenvalue. What is the eigen product of the eigenvalue? Determinant of A is the product of eigen's value. So what is the product of the eigenvalues? 9, 18, 180 is the right answer of this problem. Okay, what is that? If P of A denote the characteristics polynomial such that P of A and P of A inverse is my constant. This is my constant. I think that's again a very simple. What is the characteristics equation of the A? Lambda square, trace of A plus determinant of A. What is the characteristics equation of the A inverse? Trace of A inverse plus determinant of A inverse. Fine. Now the difference of them will be a constant. When it will be a constant? When this coefficient will be cancelled out. So that means trace of A and trace of A inverse must be same. Then only it will be cancelled out. So what is the, if I consider A, B, C, D, what is the trace of A? This is A plus D. What is the A inverse? A inverse is determinant of A. Diagonal entry must be same, so the trace of this will be A plus D over here. Now when it will be true? Only, so this is the condition you have to check. So it's a 12 minus 6 not 9 minus 8. 9 minus 8 is 1. This is the correct answer. So there is only one correct option. This is here. 12 minus 6 not 8 minus 9 is a minus 1. So this option cancel. The third option is the correct answer of this problem. Okay, what is that? 2 cross 2. There are the 2 eigenvalues, so that the product of them will be 1. Trace is 3. So what is the characteristics equation? We all knows the characteristics equation is my here. Fine. So the trace is my 3, product is my 1. So what are the eigenvalues of this? So how you can find the eigen's value? Eigenvalue is my plus minus 9 minus 4 by 2. So 3 plus minus root 5 over 2. These are the eigens values of the A. But we need the A square. So what is the eigenvalue of the A square? 3 plus root 5 by 2 whole square. 3 minus root 5 upon 2 whole square. So 9, 5, 6 root 5 over 4. 9, 5, 6 root 5 over 2. Now you want to find the trace. You can add them. So it will be cancelled out. So what is that? So 14 over 4, 14 over 4. So it's a 7 is the right answer of this problem. Because you need that A square. So you have to find the, this is the eigenvalue of A. You find the eigenvalue of the A square and so on. Okay, so 3 cross 3. There are the 3 eigenvalue. Determinant of them will be a 6. Trace will be 0. Fine. Determinant of A plus I is 0. So what is the meaning of that? Eigenvalue is my minus 1. Why? Because if you compare them, what is the meaning of that? Lambda is minus 1. So one of the eigenvalues is minus 1. So this option cancel out. Rest are there. Now trace of them is a 0. This is possible. Trace is not be a 0. Trace is not a 0. So the right answer is my here. Or there is no need to solve this. There is a quite obvious about this problem. Okay, so matrix A is given to you. You have to find the A20. So if I found the eigen's value of A, then you can find the eigenvalue of the A20s. Fine. So how you find the eigenvalues? So there are the 2 ways. Again, you can write this way plus determinant of A. Otherwise, you can simply see the sum of the each row is my 1. Sum of each row is my 1. So it means one of the eigenvalue is my 1. And we know the sum of the eigenvalue is the trace. So the trace will be my 2. So other eigenvalues also be a 1. Now, what are the eigens value of the A20? Again, it's a 1, 1. Fine. So if you look about that, the sum is not a 1. You can see here 1, 1. So it means 1 must be the eigenvalue of this. And 1 is also the eigenvalue of here. This is not true. This is not true. So the right answer is only by B. Okay, so if the matrix A has the eigenvalue 1 and 3, the what is a possible pair? So sum of the eigenvalue will be 4. The sum of the eigenvalue will be trace. So what is my A? A is my 2. So A is my first component. This option cancel, this option cancel, this option cancel. Right answer is only my B. Okay, sum of the linearly independent eigenvectors. Now remember this part. Whenever there is a question related to the number of linearly independent eigenvector, that means you have to find the sum of the geometric multiplicity of eigens value. How you find the geometric multiplicity? That means this is the dimension of kernel A minus lambda I. Fine. Now, firstly you have to find the eigens value. Clearly says that this is my Jordan block, because it's the 0, 0 here. So I can find the eigens value of this lambda square trace plus determinant 2 minus 4. So it will be my minus 2. What are the eigenvalues of this trace? Because this is the lower R there. So how I can do that? I can take this as minus of 2, minus 1 here. No. What are the factors of this? It can be written as 3 plus minus 9 plus 8 over 2, and this is 3 comma 4. Clearly say that this is the unique value. Sometimes it's a plus b square plus over 2. It is minus 3 and 4. All are my distinct. So once it's a distinct, it means algebraic multiplicity and geometric multiplicity of the each is my 1. So what is the sum of the geometric multiplicity? The geometric multiplicity of this is 1. Geometric multiplicity of this is 1. 1, 1. So the answer is my 4 is the right answer of this problem. Okay, again this is the same question. This is the number of the linearly independent eigenvectors of this. Remember, you have to find the linearly independent vectors of this matrix, not of this. What is given to you? There are the 3 cross 3. It's a singular matrix. So one of the eigenvalues is 0. 2 and 3 are the other eigenvalues. These are the eigenvalues of the M. What are the eigenvalues of the M cube? 8, 27. What are the eigenvalues of that 2M? 0, 4, 6. What are the eigenvalues of the 1? Here. Now if you add them, clearly say that this is 1, this is my here, and all are my distinct eigenvalue. So once it's a distinct eigenvalue, so the geometric multiplicity of the corresponding to this is 1, geometric multiplicity of this is 1, this. So what will be the sum? Sum is my 3 is the right answer. Okay, so the eigenvalue of the 3 cross 3 is my here. So which of them? So there is one ways you can solve like this way. You can write the characteristic equation, but I will tell you the shortcut tricks. If the eigenvalue of here, you can take the first pair, say lambda is 1. What are the eigenvalue of the A inverse? P inverse, that is a 1 over 1. So I can try for here. This is 1, 1 over 6, 5 plus 2. What is the eigenvalue of the P square is 1. So is it satisfied? No. Yes, it's satisfied. The 1 is satisfied. Look for the minus of 2. So eigenvalue of the P inverse is 1 over 2. 5 minus 4. P square will be plus 4. So is it satisfied? No. So it's 5 by 6. So it means first option is cancelled out. Look about this option. If firstly we check whether the 1 is satisfied. If I take a 1 over 6, 5 minus 2 plus 1, it is not satisfied. This option cancel out. Look about this one. 5, 2, 1, not satisfied. Is it satisfied? 5 minus 2 minus 1, again not satisfied. So I have to check this value again. So I think I have something mistake. So when it is minus 2, 4, 4, 5 by 6. So can you identify where is the mistake? So where is the mistake? Yes, this is minus 4. This is minus of P square. So it's a minus 4. So it's a minus 3 over 6. That's satisfied. I can check for the 3 also. What is the eigenvalue of the P inverse? 1 by 3. It's a 5. It's a 3. It's a plus 6. 3 is a 9. So what is that? It's a minus 3. It's a 2 over 6, 1 over 3. That's a right answer of this. A is the right answer. Okay, which of the following is not the set of the same eigenvalue? That's a very simple. There is no need to solve. Just look about the diagonal values 1 and 3. So diagonal values 1 and 3. This is the correct option. This is the 1 and 3 correct option. Diagonal values are not same. So this is not the same of the eigenvalue. If the matrix this has 1, it's a 2 cross 2. So one of the eigenvalues is 1. Then the trace and determinant will be there. So you can look about the options. If trace is 3, so it means this value is my 2. Okay, if trace is my 3, one of the eigenvalues is 1, the trace will be here. Now what will happen? The trace alpha plus 3 is my 3, alpha will be 0. So if alpha is 0, what is the determinant? It's a minus of 2, but it is plus of 2, so this option is cancelled out. If trace is my 4, what is the alpha? Alpha will be 1. So what is the determinant? 3 minus 2, 1, but it's a 3. Its option also cancel out. If trace is 5, alpha will be my 2. If alpha is 2, the determinant will be 6 minus 2, 4. So it's the right answer. If trace is my 6, then alpha will be my 3. Then it's a 9 minus 2, 7, but it's a 5. So the right answer is only my C is the correct option. Okay, which of the following is diagonal? So how you can check whether the matrix is diagonal or not? There are two ways. Find the eigenvalues. If they are distinct, then it is diagonal. Otherwise, find the algebraic multiplicity and geometric multiplicity of the eigenvalue. If both are same, then it is eigenvalue. Then it is a diagonal. So firstly, look about here. Clearly says that the determinant is 0. So one of the eigenvalues is 0. Trace will be by 2. So the other are this. Clearly say that there are the distinct eigenvalue. So yes, it is a diagonal, but we are needing a not. So this option is cancelled out. What is that? It's a lambda square. Trace will be 5. Determinant will be 6. So eigenvalues are 3 and 2. So again, they are distinct. So it is, yes, it is a diagonal, but we need a no. What are the eigenvalues of this? 2, 3, 2, because the diagonal matrix. Here is a 2, 3, 3. So now you can see they are not distinct. Then we have to find here. Algebraic multiplicity of the 3 is 1. So geometric is always 1. So we have to check for algebraic multiplicity of the 2 is my 2. So I can find a minus 2i. So what is the a minus 2i? So it will be 0. It will be 1. It will be 0. So what is the dimension of? So we have to find the geometric multiplicity, dimension of kernel of a minus 2i. So what is the rank of this? Rank is my 2. Rank of a minus 2i is my 2. So what is the dimension of this? 3 minus 2, 1. So it means geometric multiplicity of the eigenvalue is 2 is 1, but the algebraic multiplicity is 2, which is not equal. So this is not the eigenvalue. So right answer of this problem is my here. If you look about here, what is the geometric multiplicity of a minus 3i? So if I take here, this is a minus 1, this is 0, this is 0. What is the rank of this? Rank is my 1. So what is the geometric multiplicity is 3 minus 1 is a 2. That is a geometric multiplicity is my 2. Algebraic multiplicity also 2. So this is a diagonal, but this is not. So right answer is 1. Okay, so A and B are the 2 n cross n matrix. Again, n is not given to you, so I consider 2 cross 2, such that the sum of the elements in the each row of the A is my 1. So I can simply consider this is my here. B is my column is my here. So I can simply take here. What are the eigens values of this? 2 and 1. Eigens values of this B is 2 and 1. Clearly says that A transpose is my B, B transpose is my A. Which of the following is my singular? So how you can find the singular? Clearly says that when it will be the singular, when at least one of the eigenvalue is my 0. So I has a eigenvalue 1. When it will be 0? When it has eigenvalue 1. Or you can say this has eigenvalue 2. That's the meaning of this. So I can check about the B of A transpose. A transpose is my B, so it is eigenvalue is B square. What are the eigenvalue of the B square? 4, 1. But none of them is a 2, so it can never be a singular. Look about here. Similarly for okay, look about the here A transpose. Again the eigenvalues of this is my 4 and 1. If you divide it by 4, eigenvalue of this will be 1 and 1 by 4. So it is 1. It is also 1. 1 minus 1 0. This is the right answer. Okay, look about the AB. If you multiply them A into B, what will happen? It will be 4. It is 3, 2, 2. So what are the eigenvalues of this? So here 6, 8 minus 6 plus 2 clearly says that eigenvalue is not equal to 2. None of the eigenvalue is 2, so it can never be 0. None of the eigenvalue is 4, so it can never be 1, so it is also cancel out. Right answer is only D is the right answer. Okay, so A has the 4 eigenvalues, which is minus 1, 1, 1 and minus 2. Okay, that's a very simple. So that means you have to find the trace of A, trace of B. What is the trace of A? Minus 1. What is the trace of B? So what are the eigenvalue of the A raised to power 4? What is the eigenvalue of the A raised to power 4 is? You can take the power 4, 1, 1, 1, 16. What is the eigenvalue of the A square? 1, 1, 1, 4. What is the eigenvalue of the 5i is? 5, 5, 5, 5. Now, what is that? A square, that is a 1. You have to multiply this by 5. So it's a minus 5, minus 5, minus 5, minus of 20. So what are the eigenvalues of the B? 1, 1, 1. It is my 21, 1. So this is my 4. So it is 3 is the correct answer of this answer. Okay, so A is my n cross. Again, I can simply take n is my 2 cross 2. So that A square is I. A square is my A. So I can simply take A is my I. That's a very simple target. So what are the eigenvalues of the A? 1, 1. Fine. Sorry. A square is I. That's 2. Other one is I can take, if I write this as a lambda square minus of this, eigenvalue is my 1, 0. Now, if I take rank of A is trace of A. If I take as I, what is the rank of the A? Is my 2. What is the trace of A? 2. So this is correct. What is the rank of I minus A? If I take, what is the I minus A? Is it, if A is my 1, 1, 1, 1. What is the I minus of A? 0, minus 1, 0, minus 1, 0. So what are these trace of this? 0. Rank of this clearly says that it is here. Eigenvalues are either 0 or 1. Yes, that's true, because if you consider this as lambda square here, eigenvalues are my either 0 and 1. So this option will also cancel out. This option is also true. This is also true. A is a diagonal matrix with diagonal and is a diagonal matrix. What is the meaning of the diagonal matrix? It means the diagonal values are non-zero, rest are 0. But that is not true, because if I consider this here, say 10 or 100, clearly say that eigenvalue is my 0 and 1. So it means this option is not true. So A, B and C are the correct answers. Okay, A is my 4 cross 4 such that root 2 plus is one of the eigenvalue. Then root 2 minus iota is also the eigenvalue. Fine. So these are the eigenvalue of the P. Can you find the eigenvalue of the P square? So it is 2 minus 1 plus 2 root 2 iota. That is 1 plus 2 root 2 iota, and other value is 1 minus 2 root 2 iota. These are the eigenvalue of the P square. Can you find the eigenvalue of the P raised to power 4? Again scaling 1. It's a minus 8 plus 4 root 2 iota. That's a minus 7 plus 4 root 2 iota, and other number is here. These are the eigenvalue of the P4. Now you can check that which one is satisfied. 4P square. So it means I can write this number is my here. This is eigenvalue of P square. Eigenvalue of this is my plus minus 4 of this. Now firstly 4p square, if you multiply this by 4 it becomes my 8, but we need a 4, it cancel out p. Again this is cancel out. 2p square, so if I multiply this by 2 and plus 9 it will be 2 plus 9, it's a 11, but we need a minus 7, it's a cancel out. If I multiply this by 2 it will be here, and I can add them as a minus of 9, so it will be a 7 is the right answer of this problem. Okay, which of the following is the characteristics equation? So that's again a very simple target. You can take this, consider for example I can take as a first part. So lambda 1 minus of this is 1 over this, and here. Now you can see the coefficient of the lambda square is alpha. So what is the coefficient of the, but if I take this as a multiply, the coefficient of the lambda cube will be minus of beta, but we need as a 1. First option cancel out. Again here this will be 1 over m. If you take this as a coefficient is m beta m cube, this option cancel out. Look about this one here, this it is of this. So if I take as a LCM, this is lambda cube minus of this. So you can see whether it's satisfied. Yes, no, it is not satisfied because we need a minus 1, it is a plus 1. So this option also cancel out. Right answer is my D is the correct answer. Okay, which of, if m has the eigenvalue 1 and 3 corresponding eigenvector this, then m will be here. Okay, look at that. Trace of them will be 5. It's a 5, 5, 5, 5. Determinant will be 4. So minus 36 plus 40, 4. Minus 36 plus 40 is a 4. 6 minus 2, 4. 6 minus 2, 4. So all the options are satisfied. Now how you can discard them? Now we all know this is the property of this. So if I consider this, if I take as the first vector 1 minus 1, then it will be 1 something of this out of 1 and 4. So what is that? It is minus 12 minus 4 plus 8. So it will be plus 4, 5 minus 9. So it's a minus 4. Is it? Yes. That means if I take 4 as a common, so 4 is one of the eigenvalue. Second is I can take as a pair of 2, 1. If I take as a 2 into 1, it is minus 8. Minus 8 is a minus 16. 10 plus 9, 19. So it can never be written as a 1 of 2. So this option cancel out. If I consider this as a firstly 2 into 1, 18 minus 8, it's a 10. And it is a 10 minus 4, 6. It can never be written as a 2, 1. This option also cancel out. So 2, 1, 4 plus 2, 6. 2 plus 2, 5. Again, it can never be written in terms of 2, 1. That is of this. If I written here, 6 plus 2, 8. 2 plus 2, 4. You can see that I can written as a 4 of 2, 1. 4 is eigenvalue. I can check the first pair also. 1 and minus 1. So what is that? This is my 1 minus 1. So this is the right answer of this problem. Okay, so A has a distinct, A, B, C are the distinct, then which of the following is the eigenvalue? Oh, very simple again. What is the property of the eigenvalue is? We all know it will be 0. Fine. So if I say A plus C is one of the answer, then what is that? A minus lambda will be 0. So it will be minus C, B, 1. C, D minus A, C, 1, 1 minus 1, A of this. Can the determinant of this is 0? It can never be 0. Look about this A plus B. It is minus B. It's a B. It's a 1. C. It will be D minus A minus B. What is the A plus B? A plus B, C plus D. So it will be my minus C. 1. Can it be 0? Yes, it's a 0. You can see. If I can it be 0? Yes, you can see these two rows are same. If you add them, C1 plus C2, 0, 0, 0. The first column will be 0. So the determinant will be 0 is the right answer of this problem. There is no need to check about that because the answer is only one correct option. Okay, so A is a 3 cross 3 eigenvalues such that this P is the number of the positive eigenvalue, Q is the rank of this. I think that's again simple. How you can find that? So what is the rank of the A? 3 cross 3 is matrix, so the rank is my 3 here. How you can write that? It is a symmetric. So when it is a symmetric, you always look about the quadratic form. So how you can write this as a quadratic form? It's a 2 variable, it's a 2 cross 2. Diagonal entries are the coefficient of the x square, coefficient of y square 0. This is my half the coefficient of xy, half the coefficient of xy. Can you find the eigenvalue of this? Trace will be 0, determinant will be 1 by 4. What are the eigenvalues of this? So what is my P? P is my number of the positive eigenvalue. How many positive eigenvalues? Only 1. P is 1. If P is 1, Q will be my 2. That's the right answer of this. So I have to use the quadratic formula of this equation. Okay, so A has the 3 eigenvalues. So such that this determinant will be here. So I can simply write this equation of this form. So what is the root of this? Minus 3 plus 1. So eigenvalues are my 3, other is minus 1. But we know the product is minus 3. So the third one is here. So what is the trace of this? 5 is the right answer of this problem. That's a very simple target about that. Okay, so if 1, 0, 0 are the eigenvector, again that's again very simple target. These are the eigenvector. Whenever there is a question of the eigenvector, you have to solve like this way. So I consider this as a x. Firstly, if I multiply this by 1, 0, minus 1, can I get this as here? Look at that. What is the meaning of that? 1 minus 1, 0. Okay, so I can write this number as of this. What is the answer of this? 0. This is A minus 2. This is C minus 3. How I can return this number as 1, 0, minus 1? If it will be a 0. So when it will be 0? When A is equal to 2, C is equal to 3. So the first pair is my here. This could be that, this could be this. So this option is cancelled out. A, there is a third component will be the C. This option cancel, this option cancel. Now this option are there. Look about the second pair. If I multiply this element by 0, 1, minus 1, that is the second and third. 0, 3, minus 2, that's a 1. B minus C. How I written as of this? Only when B minus C will be my minus of 1. Okay, C is a 3. If C is my 3, what will be my B? So B will be my 2. So is it there? B2, C3. So it is not be there. So none of these is the right answer of this problem. Okay, so if A is my eigenvalue, minus 1 plus 1. So clearly say that the trace will be 0. Determinant is a non-zero. Once determinant 0, so eigenvalue of the A inverse 1 over minus 1, 1 over 1. So that is a minus 1, 1. Both eigenvalues are same. A inverse is minus of A? No. None of the conclusion. So right answer is my here. So you can see that no, that is also true. That is also true. Why? If eigenvalue is here, it could be this. If 1, it could be here. So A inverse could be of the minus of here. That's the right answer. Okay, so the root is a 4 cross 4. So 4 eigenvalues. So what is this is a plus minus. So lambda square will be my 1 plus minus root 5 over 2. These are the eigenvalues of the lambda square. That is a m square. We need a m4. Can you find the eigenvalue of here? I can take as a square 1, 5, 2 root 5. So 6 I can written as plus of this. What is the eigenvalue of the 8? Again I can scale them. So 9 plus 5 plus minus 6 root 5 over 4. So it's a 14 plus minus 3 root 5 over 2. Now you can check that m8. So clearly say that it's a m square. That means we need this value and of this value. So it's m square. So firstly we need a 3. I have to multiply this by 3. So this option cancel, this option, this option. So this is the right answer. I can multiply this by 3 and add them 2. You can get as the right answer. Okay, so it's a 3 cross 3. There are the 3 eigenvalues. One of the eigenvalues here. Okay, what are the other 2? You can see there the sum of the column is my 2, sum of the column is my 2, sum of the column is my 2. Since it's the same value, so one of the eigenvalues is my 2. And you can see the trace will be my 5. So what is the eigenvalues of the other? Here. So minus 2 is the eigenvalue, cancel. 3 is the eigenvalue, cancel. It is not a distinct, so we have to check whether the algebraic multiplicity and geometric multiplicity are same. So what you can do, I can check the a minus of 2i firstly. So a minus 2i will be here. This will be a 0. It will be a 1. So how you can do that? This is what is the rank. So what is the rank of this? You can see if I add them, no. So what is the rank of this? Is 3. Fine, because you can see if I add them here, again it will be rank is my 3. So what is the geometric multiplicity of this? Geometric multiplicity of 2 is not equal to 2. It means it is not diagonal. So this will also cancel out. Eigenspace each has a dimension of 1. So since this is geometric multiplicity is not 2, it means it is a 1. Okay, again we have to check the eigenvalue. Minus 4 trace, determinant will be plus of 3. So eigenvalues are 3, 1. What are the eigenvalues of this? 3 raised to power 8 plus 3 raised to power 12 and 1 raised to power 8. Clearly say that they can never be equal. So they are the distinct. It means yes, this is the correct statement. M raised to power, this is 3 raised to power 7, 3 raised to power 9, 1 raised to power 7. Again they are not equal. Again they are distinct. Yes, it is here. So both are my correct answer. Okay, so what is that? What are the eigenvalues of this? 1, 2 and 3. Then what is the value of this alpha? You can substitute this value here. When m is my 1, that is eigenvalue is my 1. What is the eigenvalue of this? 1. So 6 over 1, 1 minus 6 plus alpha. 6 is equal to minus 5 plus alpha. Alpha is my 11 is the right answer. You may consider as 2 also. Again you will get the same answer. So it's a 4 minus 12 plus alpha. 3 minus 8 plus alpha. Again you can see it's a 11 is the right answer. Okay, so it's a 3 cross 3. Determinant of a plus is 0. You can compare them. So again lambda is my minus of. If it is complex number, then plus is also be there. But the determinant will be 3. So what will be the answer of this? So if you multiply them, that is iota minus iota, and this number will be 3. So it is my plus 1, it is my 3. So what is the trace of the a square? So it is iota square, 9. That is a minus 1, 9. Answer is my plus 7. 1 and 5 are the eigenvalues of here. P is the diagonal matrix such that P inverse. So whenever there is a diagonal matrix, it will convert to the diagonal. So what are the diagonal entries? 1, 5, 0, 0 or 5, 1, 0, 0. So that is the right answer. This option is cancelled. This is the correct option. This is a cancel because this is equal to 2 of 1, 0, 0, 5. But we need only as a diagonal entries. So right answer is only B. Okay, look over the last questions. So if it is a 2 cross 2, so they have the 2 distinct eigenvalues. Which of the following must be true? What is the eigenvalue of the a square? This is my here. So if this is not equal to, can this be also not equal to? It is not true, because if I consider lambda is my 1, this is my minus 1. What is the lambda square? 1. It is also 1. So it must not be true. Okay, what about here? Fine. So what is the eigenvalue of the a raised to power n? Eigenvalues of this is here. So what is that trace? That's a sum. This is the correct option. Now I can check here. So left hand side is my cube. How I can solve that? I can simply take off this because it will be cancelled out. What are the eigenvalue of A? If it is lambda, then of this. So what is that? If you open them, it's a cube. It's a mu lambda square, it will be cancelled out. Mu square is cancelled out. It's a satisfied. Same I can check for the mu cube. This is plus of mu square. If A is my mu, then it will be of this. Again you can see it's a cancel out. So it means this is also the correct answer. An is not a scalar multiple of the identity. That is not true. Is it true? It's not a scalar identity. It means here that is not always be true, because you can write an as, because these are the eigenvalues, the 2 cross 2, they are the distinct eigenvalues, so this option is cancelled out. B and C are my correct options. So this is the way you can solve all these previous year questions in a very simple manner. I hope you can simply learn this one. You can simply follow. You can like, subscribe and comment on these videos. Thank you very much. Best of luck, students.